everybody, welcome back to a review of what we've been learning in Chapter 9 about quadratic equations, which, as a reminder, are equations that have the highest power is going to be 2, or x squared in them. And we've talked about a lot of different methods of how to solve these types of equations. We've gone through all these methods separately. Today, the goal is to put all the methods together and decide when is it best to use each one. Just so you know, there's not always one method that's best, but usually there is one method that is the most efficient, which means it's going to be the quickest and save you time. So it's helpful to know which order to think about your methods in so that you kind of have a schema in your head of first do this, if that doesn't work, then go to this method. If that doesn't work, then go to this method. Here's the order that you should be thinking of in your head as you're solving these quadratic equations. The top method is factoring. It's best to use factoring if the c value is 0 or if the factors are easily determined. It's best to use square root method if b value is 0 in standard form. Square root method is also helpful if it's in vertex form. Completing the square is kind of an extension on square root property, but it's best to use completing the square if the b value is even and the a value is 1. Because remember, with completing the square, you always have to get an a value of 1 before you begin. So it's easiest to only use that if a is already 1. That way you don't end up with fractions. Next, in your head, you should be thinking about if none of those first 3 methods worked, then you rely on quadratic formula. So any other time, you could use quadratic formula. If they're decimals or whatever, quadratic formula is always the reliable one that will work in any case. Finally, the last method you should be thinking about is graphing. Graphing is fine, but it's only really great if approximation is okay. Because a lot of times, if we have answers or roots that are decimals, you're not going to be able to find those exactly as x-intercepts on the graph. Also, we know back from the beginning of this chapter, when we were graphing quadratics, it can be really time-consuming. So definitely not the fastest because you would have to calculate the vertex, then you have to figure out the y-intercept, reflect that over the axis of symmetry, and so on. So that's definitely the last one in order of most efficient. Okay, some tips for you before we start. Always look for a GCF or a greatest common factor first. If all 3 of your terms have a common factor, you'll want to divide it out of all the terms to make the numbers smaller and easier to work with. For example, if you had to solve 3x squared plus 30x plus 9 equals 0, you might notice that 3x squared, 30x, and 9, all 3 of those terms have a common factor of 3. So what we can do is we can divide all the terms on both sides by the common factor of 3. 3x squared divided by 3 gives you x squared. 30x divided by 3 gives you 10x. And our last term, 9 divided by 3, gives us 3. On the other side, since it was already in standard form and we had a 0, 0 divided by anything will always make 0. This is going to be a lot easier to work with than 3x squared plus 30x plus 9 because the numbers are smaller. So then you could just solve this equation instead. We're not going to actually go through solving that one. We're going to do more practice with solving on the next page. Another tip is that if a, b, or c is a fraction when it's in standard form, you'll want to multiply all the terms by the least common multiple of the denominators so that you can get rid of the fractions. For example, if you had to solve 1/2 x squared plus 2/3 x plus 2 equals 0, I see that my a value and my b value are both fractions. So the denominators of those fractions are 2 and 3. You can figure out the least common multiple of 2 and 3. The least common multiple of 2 and 3 would be 6. So what I'm going to do is I'm going to go through and multiply every term in here by 6. I'm actually going to put it in the front. of each term. So notice this time I'm multiplying every single term by 6. In the first term, 6 times 1/2 would be made easier by putting the 6 over 1 and reducing 6 and 2 down to the factors 3 and 1. Now you can multiply 3 times 1 makes 3, and in the denominator 1 times 1 makes 1, but you don't need to put 3 over 1, you're just going to put 3. So that's good that there's no fraction anymore, it's just a whole number 3. Next, bring down your plus sign, and to multiply 6 by 2/3, you're going to put your 6 over 1. You can reduce 6 and 3 by their common factor of 3, so you get 2 and 1. Now multiply 2 times 2 to get 4, and 1 times 1 to get 1, but you don't need to put 4 over 1, you're just going to put 4. Bring down the x, bring down the plus sign, and finally take 6 times 2 to get 12. And on the right side, anything multiplied by 0 is always equal to 0. So if you were to solve this equation instead, you would get the exact same answers as if you were to use the equation with the fractions in it. So this is going to make your life a lot easier, whether it's by factoring or whether you use quadratic formula. We're not going to want to use fractions in those. So to make it easier on yourself, get rid of the fractions first and solve the equivalent equation instead. Okay, on the next page, we're going to go through one problem, and we're going to solve it using all 5 methods if possible. So here's the equation. I know this is a quadratic because it has x squared in it. Remember, when the directions say solve, we know our answers are going to be x equals a number. So first method that we always want to try is factoring. In order to do factoring, you want to put it in standard form. So we'll move the 12 over by subtracting it. Now you take a times c. In this case, a is 1, c is negative 12. So ac is negative 12. Write down the b value, negative 4. You have to think of 2 numbers that multiply up to ac and add up to the b value, negative 4. What 2 numbers can multiply up to negative 12 and add up to negative 4? That would be negative 6 and positive 2. Since the a value was 1, we're going to skip straight to the factors by using the shortcut x and then write the first number and then put your variable x and put the second number is positive 2. Since we are factoring it, since we're solving it, you can't just stop after you factor. When it says solve the equation, then the next step after you factor is to split these factors up with the zero product property. We know that if 2 factors multiply together to equal 0, then either one of the factors is equal to 0 or both of the factors are equal to 0. Now these should be easier to solve because they're just linear equations with x to the first power. So you can move the 6 over to the other side by adding it, move the 2 over to the other side by subtracting it. So our final answers are x equals 6 and x equals negative 2. Next, let's try the next method up. If factoring wasn't possible, then you go to the option of square root property. However, in this problem, square root property is not possible. The reason why it's not possible is because it doesn't have a b value of 0. The b value is negative 4, not 0. All right, so go ahead and write down this is not possible because b equals negative 4, and it has to have b equal to 0 to use square root property. If it's not possible to use square root property, you should be able to complete the square. So remember the formula for complete the square is b divided by 2 squared. In this case, our b value we already said is -4. -4 divided by 2 makes -2, and -2 squared makes +4. Whatever you get when you complete the square, you add that number on both sides. So I'm going to put +4 on both sides of the equation. Remember, for completing the square, you have to have it set up in the format where you have ax squared plus bx equals the constant, and the constant has to be on the other side of the equal sign. After you add the completing the square value on both sides, now you factor the left side. So in order to factor x squared minus 4x plus 4, you want to think of two numbers that multiply up to equal AC or +4, and they add up to equal -4. What numbers multiply to equal +4 and add to equal -4? That would be -2 and -2. After you figure out the two numbers, you can skip straight to your factors, x minus 2, x minus 2, since the a value is 1. On the right side, you can go ahead and combine together 12 plus 4 to get 16. Then, the whole point of complete the square was that you got a perfect square. X minus 2 times x minus 2 could also be written as x minus 2 squared. Remember, this number in the factor will always match the number that you got from b divided by 2. Now that you have a perfect square on one side, a real number on the other side, you can finish it up by using square root property. So next you're going to take the square root on both sides. In front of the side with the real number, you have to scooch it over and include plus or minus. The square root and the perfect square cancel each other out. So on the left side, you just have x minus 2. On the right side, you have to see, can you simplify square root of 16? The answer is yes, because it's a perfect square. The square root of 16 is 4. You could also find that out by making a factor tree, but it would be better if you have your square roots memorized, your perfect squares at least. Once you get it to this part, now you're going to split it up. X minus 2 equals +4, or x minus 2 equals -4. So you're splitting up the plus or minus. One's +4, one's -4. Solve each linear equation separately, but both of them you're doing the same thing. You're adding 2 on both sides. For one answer, you should get x equals 6. For the other answer, -4 plus 2, you should get -2. So our two answers are x equals 6 and x equals -2. Notice those are the same two answers that you got when you did factoring. However, it was a lot faster and more efficient to do factoring than it was to do completing the square. Next, let's do quadratic formula. For quadratic formula, you have to have it in standard form. So we already talked about how to put this one in standard form. It would be x squared minus 4x minus 12 equals 0. So I have an a value of 1, a b value of -4, and a c value of -12. Write down the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac over 2 times a. Now fill in your values for a, b, and c. When you fill them in, you need to put them in parentheses. After you fill in the values, now you have to go through and simplify. So a negative times a negative makes a positive, which means that should be +4 plus or minus the square root of, and then -4 squared would mean -4 times -4, so +16. -4 times 1 would make -4, and then -4 times 12 would make +48. And in the denominator, you have 2 times 1, which equals 2. Now add together the discriminant, the 16 and the 48. You should get x equals 4 plus or minus the square root of, let's see here, 64 over 2. Simplify the radical. 64 is a perfect square. It makes 8. So we have 4 plus or minus 8 over 2. Now you split it up. It's x equals 4 plus 8 over 2, or x equals 4 minus 8 over 2. You have to do the numerator first. 4 plus 8 makes 12 over 2. 4 minus 8 makes negative 4 over 2. For the first answer, 12 over 2 is 6. For the second answer, negative 4 over 2 is negative 2. Again, notice we got the exact same two answers, but factoring was definitely faster. Okay, finally, we can solve this by graphing. In order to solve it by graphing, you have to get it in standard form first. So we're trying to graph the equation x squared minus 4x minus 12 equals 0. Remember, when you're graphing it, you can go ahead and ignore the equals 0 for a minute and just graph the x squared minus 4x minus 12. So in order to graph that, remember step 1 is to find the axis of symmetry by using the formula x equals negative b over 2 times a. In this case, b is negative 4, a is 1, so we get 4 over 2, which equals 2. So my axis of symmetry is x equals 2. Let's go ahead and put that on the graph. Remember, that's always a vertical line through that x-intercept of whatever x value you got. Take your axis of symmetry and find the vertex for step 2. In order to find the vertex, you take the x value that you got and you plug it back in to find the y value. So you're going to do 2 squared minus 4 times 2 minus 12. So 4 minus 4 times 2 minus 12. You do the exponent first. Now you can multiply 4 minus 8 minus 12. Now you can add and subtract. 4 minus 8 would be negative 4. And then negative 4 minus 12 would be negative 16. So put this value together with the x value. We got a y value of negative 16 when the x value is 2. So 2 comma negative 16 is the vertex. Go ahead and put that on your graph. Step 3 is to find the y-intercept. That's always going to be 0 comma c. So in this case, the y-intercept is 0 comma negative 12. Go ahead and put that point on your graph. Next, you reflect the y-axis point, the y-intercept, over the axis of symmetry. So that point should land on 4 negative 12. This is nowhere close to our x-axis. In order to find more points closer to the x-axis, we can plug in other values for x. So now you might want to make a table. We already know that when x is 4, y is negative 12. So we can guess, okay, maybe let's move over 1. Let's plug in 5 for x and see what do we get for y. In the equation, we would have to do 5 squared minus 4 times 5 minus 12. That's going to be 25 minus 20 minus 12, which gives us negative 5 minus 12, or let's see, positive 5 minus 12, which is going to be negative 7. So when x is 5, y is negative 7. That creates the point 5, negative 7. So that didn't hit the x-axis yet either. Now go over one more value. Let's go to an x value of 6. When you plug in 6 on the graph into the equation, you get 36 minus 24 minus 12, which is equal to 0. So an x value of 6 gives you a y value of 0. That's an x-intercept. In order to find the other x-intercept on the other side of the parabola, you'll reflect this over the line of symmetry. So if this is 4 units away on the right, you're going to have to go 4 units away to the left. That'll land you at an x value of -2. So we know that there's going to be an x-intercept also at -2. After you graph it, you write your final answers. So our answers come from the x-intercepts, and they are x equals -2 and x equals 6. Notice those are the exact same answers as what we got in the other 4 methods that we used, but graphing was definitely the most difficult, took the most time. So that's why it's best to use factoring first, then square root property, then complete the square, then quadratic formula, last result is graphing, or if it just says to estimate your answers, graphing would be fine too, or if you had your graphing calculator. Which method would have been most efficient and why? Factoring would have been the most efficient because the factors were easily determined. We easily figured out that the factors would have to be x plus 2 and x minus 6. So since those were easily determined, factoring definitely would have been the most efficient method. Okay, in order to practice this and practice figuring out which method is best, I'm giving you the next 6 questions to decide what method do you want to use. Always start by trying factoring first, and then if that isn't the best, then you move on to square root property, then you move on to complete the square, then last resort quadratic formula, and then if it says to estimate your solutions, that's when you're going to want to go for graphing. You have to use every method at least once. So make sure you use all 5 methods, but there's 6 problems, so you're going to end up using one method twice. Tell me what method you're choosing, why you chose it, and then solve the question. Solve the equation. Once you have the equation completely solved, circle or highlight your final answer, and then move on to the next question. This is your homework for your online day. You just have to finish up the next 6 problems, tell me the method, explanation, why you chose that, and solve it. And then once you're finished, save your work as a PDF and submit it on Schoology. I hope you guys have a great rest of your day. Thanks so much for taking your time to watch this, and I'll see you back tomorrow. Bye, guys.